Good morning, one and all. This is Dr. Diana. Welcome to session 23 on modern software engineering. We have been looking into Unit 4 and 5, then we have revised them. Now we started with revision of Unit 3. Unit 3 mainly deals with agile release process. When we talk about release, we saw that it is pushing your code from the development phase to production phase and then into deployment phase. So any level of pushing that is made to pass from one phase to another is called as releasing. We have been revising about how to come up with a bug-free release. In agile development methodologies, as we know that we are working parallelly in multiple teams on multiple aspects, and that the design is basically incremental in nature, it is difficult to dedicate some time exclusively for testing. So in that case, our development methodology itself should be sustainable and it should be tested by the time we complete development. In order to achieve this, we have looked into how the test-driven development cycle works. In the test-driven cycle, we saw there are 4 steps: the thinking, red bar, green bar, and the refactoring phase. All of these 4 phases are repeated in iteration, so that by the time you complete one particular feature or a story, it is always well designed, well coded, and well tested. So that is the main aspect of test-driven development. When we follow test-driven development strictly, we know that we will get a bug-free release. But we have looked into certain strategies that we can adopt while coming up with a bug-free release. So our idea is to achieve 0 bugs. To do this, we have seen 5 different principles, and these 5 principles are writing fewer bugs, elimination of bug breeding grounds, fixing bugs quickly, then testing the process and fixing the process. So these are the 5 things we have seen in the earlier session. Now we will move on into how version control works in a parallel agile development environment. What is version control and how do we go about it? And when we talk about version control, we see in agile strategy or in agile development environment, there are about 10 teams working parallelly. One of them may be on the design phase, the other one on the development phase, the other one might still be gathering their requirements. So this is how the agile unit typically looks like. So in that model, to maintain a single piece of integrated code becomes very difficult. So in version control, we concentrate on our project artifacts in a single authoritative place. So an authorized place where you can place all your code is required. A version control system provides a central repository or a central database kind of that helps coordinate changes to files and also provides a history of changes that has been made to the files put inside the repository. A project without version control may have a lot of small bits and pieces called as snippets of code scattered among all the developer machines. So imagine there are 100 people working together on the project. Each 100 of them will have bits and pieces of the code on their own machines. And when they might have in their networked drives or even in their removable disks. And when I am ready to come up with the release, it is very difficult to integrate all of this code and then release the software. And when we talk about release, we also should talk about build. Build is the process of integrating all the code that have been developed by the programmers and all the files that are required to run these programs on a client machine. So build not only has the program code, but the platform that is required to run this code on a client machine, along with all the machine and the dynamic libraries that go along with it. So a build is required to deploy your production code. Once your production code is tested and ready, it is executable only on your machine or the developer machine. But our intention is to execute the same file on the client machine. So all the other additional programs required to execute this production code on the client machine and call it as the deployment code, we need to do a process called as build. So the build is integration of your production code along with the platform and the machine libraries that can help you run this production code on a client machine. So the build process will become very hectic when you have bits and pieces of your code everywhere in the programmer's network, and integration of that code will be difficult. Along with that, you will have an additional problem of integrating all the machine required files. So the build process will involve 2 or more people scrambling to find the latest version of several files, trying to put them in the right places. Now when you think about that, you have got 100 people writing different functions and modules. When you try consolidating all of that, you imagine there are 2 people going out and collecting all the code and then putting it into one machine, and they don't know where to place each of them and how to name each of these files as, because naming conventions when you try accessing some of the code may not work. So all of these are making things very much complicated for releasing the production code into the deployment code. So how do we manage? So we are going to follow a repository where I can place all of the code, and every time the programmer needs the code, they can take it out of the repository, make changes, put it back inside the repository. That's the easiest way of doing things. So a repository is the master for storage for all your files and their history. It is typically stored on a version control server. Each standalone project should have its own repository. So a version control server is a server that can specifically keep track of the changes made to your production code every step of the way. Every time you take out, it will maintain a version. Every time you put back inside, it will maintain a list of changes that have been made to the code. And when we have multiple projects running on the same organization, each of these projects will have their own repositories inside the version control server. So you have one single repository, and whenever the programmer tries to access it out of the repository, they are going to use it inside a sandbox. So a sandbox is also known as a working copy. A sandbox is what the team members work out of on their local development machines. So each of the programmer will have a sandbox into which they can draw code from the repository, make and start making changes. Don't ever put a sandbox on a shared drive. So it should be a local copy, completely local to the user alone. If other people want to develop, they can make their own sandboxes. So each programmer will have their own sandbox. The sandbox contains a copy of all the files in the repository from a particular point of time. So the version control system, imagine I have a version for this particular day. When everybody draws out their piece of code into their own sandboxes, they'll receive a version of the code that is last updated. So they'll receive today at 9 p.m. and 9 a.m. in the morning, I will take my bit of code. When somebody else tries to download something from the repository into their sandbox at afternoon 2 o'clock, they will still receive the code that is downloaded in the morning. So the same way, the version control server maintains a milestone, and any milestone in the time zone. So if anybody tries to download from the repository into the sandbox, the previous milestone version is what they will receive. The sandbox contains a copy of all files in the repository from a particular point of time. And we also have to create this sandbox and a checkout copy of the repository. In some version control systems, it means update and lock. Now, when I have completed my updation in the sandbox, I put this inside into the repository. Then it is called as update and lock. When you say update, when you update your sandbox to get the latest changes from the repository, you can also update it to a particular point in the past. Now, when I try downloading it from the sandbox, I can tell the time. I can download the latest copy, or I can tell the time, 6 months back, how did my code look like. So that point of time I can mention and then draw that particular set of code as well. Now, lock is something that prevents anybody else from editing that file. Imagine I'm working on an incremental design. So I'll have a basic model upon which I'm working on. There may be 2 or 3 teams working on incremental design. So the basic model should not be changed by any of them. So you keep that particular file from editing. So you leave it in lock until people have got their own versions, developed it, checked it, tested it, they put it back inside the repository. That particular basic model will not be editable for any of them. And then you call the operation called check-in or commit. It helps you check the files in your sandbox to save them into the repository. When you there are options to revert certain things in your sandbox. Revert your sandbox to throw away any changes and return it to the point of the last update from the repository. This is handy when you have broken your local build and you can't figure out where to start working again. In that case, you can revert back to your previous state and then start from there. Sometimes reverting is faster than debugging, especially if you have checked in recently. So if your code is broken, it's easier to revert back and then to start. Then you have certain features like tip or head. The tip or the head of the repository contains the latest changes that have been checked in. When you update your sandbox, you can get the files at the tip. So from there, if you start making branches, I think it will be effective. And then you have something called as the tag or a label, which marks a particular time in history of the repository, allowing you to access it again and again. Then there's a rollback operation, a check-in to remove from the tip of the repository. This mechanism for doing so varies depending on the version control system that you use. And then you can branch and merge. A branch is when you take a particular version from the repository and split the repository into distinct alternate history, a process known as branching. So you have 2 branches maintained parallelly, one after more like you divide history into before Christ and after Christ, same way. So you will have to after this change and before this change, you have 2 different lines of code, and people start working parallelly on the before version and on the after version. So it becomes a branch in the repository. And when you decide that either of the options that you have started following earlier lead to the same outcome, then you can still merge both of these production codes into one. That is called as the merge operation. It's the process of combining multiple changes and resolving any conflicts if it is there. And if 2 programmers change a file separately and both check in at the same time, the second programmer will need to merge in with the first person's changes. So everybody working on the same file might have to merge it together and then put it back inside the repository. And the major difficulty that we see with the version control server is maintenance of concurrent editing. If multiple developers modify the same file without using version control, they are likely to accidentally overwrite each other's change. To avoid this pain, some developers turn into a locking model of the version control. When they work on a file, they particularly lock it to prevent anyone else from making changes. The files in the sandboxes are read-only until locked up. So if you have to check out a file in order to work on it, then you are using a locking model. And this version control helps with one particular aspect called as time travel. One of the most useful thing about the version control is the ability to go back in time. Now you can update your sandbox with all the files from a particular point in the past. This allows you to use differential debugging, which means when you find a challenging bug that you cannot debug normally, you can just like that go back in time to a older version of the code when the bug didn't exist at all, and then you can go forward a bit, then a backward a bit, forward a bit, to isolate exactly why that bug came into existence. So if you move back and forth in time, you'll be able to identify which piece of code actually caused that bug. So it helps very much in debugging, and you can review these changes in the check-in and check-out and identify the root cause of the bug. And the main thing we will have in mind about the version control is to keep it clean. To summarize all that we have seen, we will see that this code goes through 4 levels of completion. The first is the broken code. This happens only in your sandbox. Then you builds and passes all the tests. All versions of your repository are at least at this level. So they should have passed through the build, and then they should have taken up all the tests. And then you need to be ready to demo to stakeholders. Any version marked with an iteration X tag is ready for stakeholders to try. So this is how they maintain inside the version control system. Ready to release to the customers can be marked with release tag Y. So every time I see a tag X on the code, it's for demonstration to the stakeholders, and every time I see a piece of code with tag Y, it is ready for release. And the other main aspect of faster releasing is called as the 10-minute build. Usually building takes a lot of time, more than expected actually, because we are trying to integrate all pieces of code that the programmers have been working on parallelly, and then you derive all of them, integrate all of them, and then you do an integration testing, and then add on all the required machine files to it so that you can push it into deployment. But this is a very, very difficult process. So to eliminate build and configuration hassles, you can go for an automated build. An automated build is the easiest way to improve productivity and morale. How to automate? There are plenty of useful tools available depending on your platform and language that you are using for development. If you are using Java, you can take a look at ant.in, .NET, nant, and MS Build are very popular. When you make it in an old standby for C or C++, you can go with Perl, Python, Ruby. Each of them have their own preferred tools for building. So you can use any of these tools and then start building your deployment code. When we try to build, when should we plan on automating the building process? It should be noted that it is most difficult to come up with a build at the starting of the project. So at the start of the project itself, you should be able to automate. At the start of the project, in its very first iteration, set up the bare bones of the build system. So it is from that point onwards that an automation is very, very essential. The goal of this first iteration is to produce the simplest possible product that exercises your entire system. So use the build script to configure the integration machine, and don't configure it manually whatsoever. If you find that something needs configuration, modify the build script to configure it for you. Don't try to do it yourself. So this is how we plan on coming up with a build, and then you also can do it using the automated tools. Now these are some of the strategies that help us in faster release. A release is something where we try to push our development code into production code and our production code into deployment code. So at each of these levels, when we change the phase of the code into another, we say it is called as a build or a release. Now this release process is very difficult in agile environments, so we follow certain strategies. The first one we looked into was no bugs, and then we looked into version control and the 10-minute build strategy. For now we will close here. We will look into the rest of the unit 3 in the next session. This is Dr. Diana signing off. Thank you one and all.